All right, so with application problems and the derivatives and things like that, what we're going to do is we're going to get a actual value for, some kind of derivative. But when we write it out, we're going to write it only to so many decimal places. But then if we need to calculate the rate of change, as in this problem, and in most of the problems we're going to look at, then we want to use all the decimal places to get the values. Otherwise, you're going to have a lot of rounding error and you're not going to get the correct answer. It's going to be rounded maybe too many places one way or the other when you do the derivative formula. Okay, so looking at this one, we have the future value of $1,000 after T years invested at 7% compounded continuously is given as f of t equals 1,000 e to the 0.07t. Okay, now this one, we could write directly because we know compounded continuously is a e to the t kind of function, and it's e to the rt to be exact. And then we just have to multiply that by our principal, and that gives us our thing because it's p e to the rt, pert. Okay, that's a compounded continuously. So what we're supposed to do is write the rate of change function for the value of the investment. So what does that mean? Well, that says write what does f prime of t equal. Okay, well, f prime of t. Well, here we have 1,000. Now let's look at this. We don't have just a plain e to the x. So what I think I want to do is I want to convert e to the 0.07. I want to convert that to something like a b to some just b value, because then if I think about that, that's e to the 0.07 to the t, and then if I take e to the 0.07, that gives me b, and that's to the t, and I can easily take the derivative of that because that's just going to be the ln of b times b to the t. But when we have this 0.07t here, I don't know exactly what to do because I know if I have e to the x, the derivative of that is e to the x, but that has to be x, and I have 0.07x technically if you want to change variables, but I can't do it with this way. So I'm going to have to convert doing that, and then I can take that derivative. So 0.07, if I take that e to the zero point zero 0.07, again, this is going to give us a rounded number. And so e to the zero point zero 0.07 is approximately 1.0725. And so that will be what's taking to the t power. So maybe let's not write f prime quite yet. Let's write our converted f of t. So that's going to be 1,000, and then it's times, then 1.0725 to the t. Okay. Now with that, I can take the derivative simply. That's just going to be f prime of t. And I have 1,000, my constant, times. Now I have to take the ln of that, ln of 1.0725 times, and then I just take the 1.0, maybe I'll put this one in parentheses this time, 725 to the t. Okay. So that would be my function. And again, this here part is really e to the 0.07, which is this plus a lot more digits out here. So when I do this, what I'm going to actually plug into, if they say, in this case, calculate the rate of change of values in 10 years, that means I have to find f prime of 10. And when I do that, that's going to be 1,000 ln, and I'll take e to the 0.07, and then times, and yeah, then that's going to be e to the 0.07 times 10, and that should give me the value. That way I'm back to actual, all the decimal places going to be included in my value. So if I type that in, 1,000, and then I have ln, and I'll have e to the 0.07, arrow down, and then times e to the 0.07 times 10. That gives me the following value. It says 140.9626895. And when we do this, that's going to be kind of the unrounded number, but I'm going to kind of look here and see I don't know. Let's round it, because rate of change basically is not going to be needing to round to like 2 decimal places. We're not going to round to the penny. We could keep this whole thing as our rate of change. So it's going to be dollars, and it's going to be per year. Okay, so if we wrote our actual units here, that would be the function dollars per year. And then when we plug it into our calculator, we could keep the whole thing here because that's the rate of change. So, it's changing, changing, changing. So we could leave it that, or if we wanted to, we could round to maybe 3 decimal places. That gives us one more decimal place than the pennies. And so that would be $63 and then per year. Okay. So that's how I would do that one. Again, the key thing is we couldn't just directly do this. We had to convert it to b to the t, and then after that, when we had any place we had 1.0725, we remember that was e to the 0.07. So when we plugged it into our calculator, that actually gave us all the possible digits that were going to be correct. All right, so let's stop there and we'll come back.